Water moving into the cell. Well, if a hypertonic solution makes your cell shrink, hypotonic is going to make it swell. It's going to start to swell, get bigger. Ultimately, it can make it burst. Right? If it bursts, that's the end of the cell. Right? Kills the cell. In this case, a hypotonic solution would cause water to move in. Hypo means low concentration. So in this case, there's actually more stuff, more solute, whatever we're talking about, inside your cell than in the solution. So for example, pure water, right? I use the example talking about like saltwater fish, seaweed, right? Different types of ocean organisms, and saying that they've evolved and adapted and lived their whole entire lives in that salty environment, and to them, that's normal. That's what they're meant for. Their inside is just as salty as the ocean is. They're meant to be that way, right? If you take them and you put them into pure water, the pure water is going to be low concentrated. It's not going to have much salt. Their bodies, their cells are actually going to have more salt than the pure water, which means that that pure water is going to move into all those cells and start to swell up all those cells, and you can actually drown the cells, right? It's not okay to take organisms that are meant for salt water and stick them in fresh water. It's toxic to them, right? You drown their cells. You can start to burst their cells and destroy their cells. So a hypotonic solution is low concentrated. An animal cell is going to start to lyse. Remember lysosome, to break, all right? The cell is going to start to actually rupture if it gets too big. In the case of a plant cell, that central vacuole is going to be nice and full. Cytoplasm is going to be all expanded, pushing out on the cell wall. That plant is going to be really, really upright and firm. But if you go too far, if you water it too much, you can burst the central vacuole. You can do damage. Right? It's just going to take a lot more water to do damage to a plant cell because it's got that whole central vacuole to hold all the extra water. It's designed to hold extra water. Then we got when water moves in and out at the same rate. If water's moving in and out equally, that means that the cell shouldn't really change too much. Right? There isn't going to be any one or other direction for the water. And that means that the cell is actually at equilibrium. It's already reached the point where inside is the same as outside. This type of solution is called isotonic. Iso, we're talking about the same concentration. Right? That means that the concentration of solute is the same inside the cell as it is outside the cell. So, for animal cell, that's normal. Right? The animal cell is perfectly fine, perfectly functioning. In the case of a plant cell, that actually means that the central vacuole is not as full as it possibly could be. All right? If some of the water is leaving, that plant cell could probably be holding more. But that's okay. All right? It's still healthy, it's still fully functioning.